Hey everybody, we're going to get started here on a couple things. We're going to kind of go back and notice it says 1.6, classifying polygons. A little bit of review. We didn't do this section per se, but the material in it we've covered in many ways. So I'm going to go through it rather quickly. It's mostly definition terms. The main reason I'm doing it is because we need it for the next one, dealing with polygons and dealing with their angles and stuff. So a couple things I want to make sure we remember. Okay. First of all, we know what a polygon is, I think, but definition-wise, it is a closed plane figure. Okay, is what it refers to. And it has sides. Sides are the segments. Okay, has angles, and those are the we actually call the vertex or the vertices. It's the end points of those segments, and that's also where the angles are. Okay, now there's two terms. One is convex, and the other one is concave. Convex is what we normally think of with a polygon, so I'm going to write normal polygon. And I think I've mentioned it before. And concave is, I like to call it a caved in polygon. And it's what we don't normally think of. And in fact, what you see, and every time we've dealt with the term polygon, the word convex was in front of it. So, convex would look something like this. Okay. Whereas a concave one would look something like that. Okay. See how it's kind of caved in here, I call it, that idea. There's a more formal definition, but it's not that important. Okay, n-gon is any-sided, like a variable polygon, and we'll come back to that because it's going to be about the names. And then a couple other terms we've used: these equilateral, sides equal, equiangular, angles equal. And then a term that got cut off here is regular. Okay, that means all sides and angles equal. Okay, that term is the more important term of any of them. I think the other thing we kind of need to remember is, a three-sided shape is called a triangle. Four-sided is a quadrilateral. We did this before. Five-sided is a pentagon. 6 is a hexagon. 7 we refer to as a heptagon. 8 is an octagon. 9 is a nonagon. And we'll say 10 is a decagon. There is an 11 and 12. We'll go with those as well. I think we mentioned them. Undecagon. And 12 is dodecagon. So those were terms that we kind of needed to know. All right. So just a couple examples dealing with these terms. Nothing too grand. A couple things here. So this one here, first of all, a polygon. This is kind of defining things a little bit more detail. A polygon is a closed plane figure with the following properties. It is formed by 3 or more segments that we call the sides. It has to be at least 3. Okay. Each side intersects with exactly 2 sides. One at each endpoint, so that no 2 sides with a common endpoint are collinear. Okay, in other words, they are separate from each other, the sides. They're not going to line up together. Each endpoint of a side is called a vertex. Okay, plural of that is vertices. And a polygon can be named by listing the vertices in a consecutive order. In fact, you can see here A, B, C, D, E. Or we could have said C, D, E, A, B. Typically, we go in a clockwise fashion around it. You just pick a letter and then go around. So we could say D, E, A, B, C. We don't want to do things like D, B, E, A, C. That doesn't make sense. So you go around the shape. And typically, we do go clockwise. Okay? All right. couple other little terms here, things to deal with the terminology we started off with. First is dealing with stating whether this is a polygon, and if it's convex or concave. So if you look at A, that is not a polygon. Hope you can see why. There's this line here in the center, this one here, that means it is not a polygon. There shouldn't be lines inside in the interior. Okay. B, that is a polygon. It is a convex polygon. Okay. And then C is concave. It's an example of a concave polygon. Okay. All right, 2 examples. Yeah, you could pause it and see if you got it, or just look at them real quick and see if you get them. So yeah, number 1 is a polygon. It is convex. 2 is not a polygon. Now, the reason it's not in this case is this side right here is not a straight line. It is curved. It's not a line segment. It's kind of an arc. All right, so that means it's not a polygon. It can't have curves to it. They all have to be segments, the sides do. All right, a couple other things here. Classify this polygon by the number of sides and tell whether the polygon is equilateral, equiangular, or regular. The polygon has 8 sides. Okay, so I think, if I remember, I did that quickly and I shouldn't have. 1, 2, 3, 4, 5, 6, 7, 8. Yeah. So we would call that an octagon. It is equilateral and equiangular. You can see all the angles are the same, all the sides are the same, so it is a regular polygon, regular octagon. Okay? All right. An example here dealing with him, we'll get into a little bit of math with these. The head of a bolt is shaped like a regular hexagon. Regular means, again, all the sides are equal. Boom, 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 boom. And the angles. Find the lengths of the side. First, write an equation. Use it the fact the sides of a regular hexagon are equal. Okay. That's an E. And so we're going to write and set those equal to each other. 5x minus 1 equals 4x plus 3. If we solve this, I'm going to do it off the side. They don't give us much room here. You know, what would we do? A little bit of algebra we haven't done in a little while. So you get x minus 1 is 3, and x is 4. Okay? And again, x is 4. So then they want to know how long, find the length of each side. They're all the same, so we just got to plug into one of those. We could have used 4x plus 3 or 5x minus 1. It doesn't matter. So we put in the 4. So 4 times 4 is 16, plus 3 is 19. Okay, so the length of each side is 19 millimeters. All right, so that's the idea. So then the last 2 examples here, you might want to pause and try them for yourself. All right, so number 3, tell whether the polygon is equilateral, equiangular, or regular. Let's also classify the polygon by the number of sides. There are 4 sides, so that's a quadrilateral. Okay. Is it equilateral? Are all the sides equal? No. Is it equiangular? No. So then it can't be regular. So it's just a quadrilateral. It's none of those. Okay. The expression 4x plus 8 degrees and 5x minus 5 degrees represent the measure of 2 of the congruent angles in example 3. Find the measure of the angle. Well, if they're congruent, we can set them equal and solve. Okay. So minus 8. X minus 5, x is 13. Okay, so x is 13. So I got to plug into one of them. It really doesn't matter which one. So 4 times 13 plus 8. Let's see, 4 times 13, 52, plus 8. Is that right? No, 42, sorry. 42 plus 8. Yeah. Nope. Let's do it. I'm making mistakes here. I should have worked this one out ahead of time. So 4 times 13. I had it right the first time. 52 plus 8 is 60. Okay? So that the measure of each angle is 60 degrees. All right. So I'm going to give you a few things to try in this section. Not much. We're not going to spend much time on this section. The next video would be on chapter 8, which is a little more involved mathematically. Okay?